Today we'll be focusing on the ACS Chapter 9, which is Solutions and Aqueous Reactions, Part 2. So the question says, 20 grams of sodium hydroxide is dissolved in 250 grams of water. The first question is, what is the molality of the solution? And the second question is, what's the mole fraction of sodium hydroxide in this? For part A, we're finding the molality, so we'll be using this equation, which is the moles of solute divided by the mass of solvent, specifically in kilograms. So we must start by using the solute, which is sodium hydroxide, that mass, and converting it to moles so that we can plug that into this equation over here. And to do that, we would do 20 grams of sodium hydroxide. Dimensional analysis, and then divide that by the molar mass of sodium hydroxide, which is 40 grams per mole. And in that case, we would get the number of moles, which is 0.5 moles. So after we found the number of moles, we can plug that into our equation. And this is a substitute for molality, which is a lowercase m, only a lowercase m. And so we'll put our 0.5 moles in our numerator. And then our mass of solvent in kilograms. We're given our mass of solvent in grams here, so we'll convert. We'll convert 250 grams of water by dividing this by 1,000. And here you can see that our units cancel out, and thus we can get 0.250 kilograms. Now, we're going to come over here and substitute that into our equation. Kilograms. Okay. And then, once we plug that into our calculator, we're going to get a molality of 2 mole. Okay, now for part B of the question, it says, what is the mole fraction of sodium hydroxide in the solution? So to find that, we will be using this equation here, which is the mole fraction, aka chi, is equal to the moles of substance that they're asking for in this case. That would be sodium hydroxide divided by the total moles in the solution. Now, if you can recall, to the first part of the question, we had found the number of moles of sodium hydroxide in the solution by using conventional analysis, and we concluded that it was 0.5 moles. Now, in addition to that, we're going to have to find the number of moles of water, so we're going to use the same method. In this case, we're giving 250. In this case, the molar mass, instead of being 40, it would be 18 grams per mole. And that was found to be, we're going to use 1 decimal place again, so that would be 13.9 moles. In this case, we can go ahead and substitute the moles of sodium hydroxide directly into the equation. That would be 0.5 moles. And again, this is in our numerator because they're asking for the moles of the substance, which is only specifically sodium hydroxide in this case, divided by the total moles. So in that case, back up here, we would add 13.9 and 0.5. And we would get a total of 14.4 moles. We're going to substitute 14.4 moles into this equation. And then our mole fraction is now concluded to be 0.0347. And in this case, our units in the numerator and denominator cancel out, so it would just be the number 0.0347. Thank you for watching.